The particle has velocity v of t equal t cubed minus 10t squared plus 24t meters per second. Find the displacement and the total distance traveled over the time period t equals 0 to t equals 6 seconds. To find the displacement on the interval 0 to 6 is to simply find the change in the position s of 6 minus s of 0. And so using the net change theorem, by the definition, this is the definite integral from 0 to 6 of the rate of change of the position, which is the velocity, and the velocity is given t cubed minus 10t squared plus 24t. To find the antiderivative of t cubed minus 10t squared plus 24t, we simply use the power rule for each of the terms. The antiderivative of t cubed is t to the fourth over 4. Minus 10, the antiderivative of t squared is t cubed over 3, and the antiderivative of t is t squared over 2. We keep writing the constant multiple in the front. Simplifying this, we have 1 over 4 t to the fourth minus 10 over 3 t cubed plus 12 t squared. Plug in 0 and 6. If we plug in 6, we have 1 over 4 times 6 to the fourth power minus 10 over 3 times 6 cubed plus 12 times 6 squared minus, and if we plug 0 into each of these terms, it will be 0. To simplify this, we factor out 6 cubed. We end up with 1 over 4 times 6 minus 10 over 3 plus 2. 12 is 6 times 2. This is 6 cubed. 6 over 4 is 3 over 2 minus 10 over 3 plus 2. And this will be 36. The unit is meters. The displacement over the interval 0 to 6 is 36 meters. To find the total distance traveled, we will first need to find where the velocity is 0. And to do that, we set the velocity equal to 0 and we solve for t. This is t cubed minus 10t squared plus 24t equals 0. Factor out t, we have t squared minus 10t plus 24 times t equals 0. And we can factor this out further. T times t minus 4 times t minus 6 equals 0. Negative 4 times negative 6 is positive 24, and negative 4 plus negative 6 is negative 10. And so t equals 0, t equals 4, t equals 6. This is on the interval 0 to 6. We would need to use 4 as a cut point. And this is the sign chart for the velocity. If we pick any number between 0 and 4 and plug it into the velocity, 1 for example, we will see that this is 1 times 1 minus 4 is negative 3, 1 minus 6 is negative 5, so a positive times a negative is a positive. Similarly, if we pick any number between 4 and 6, so that's 5 minus 4 is positive, but 5 minus 6 is negative, and so a positive times a negative is a negative. And so we see that this particle is moving forward from 0 to 4, and is it moving backward from 4 to 6. To find the distance traveled, we first need to find the distance traveled during the first interval, and this is the integral from 0 to 4 of the velocity. It is the same velocity that we use to compute the displacement. And so this is the integral from 0 to 4 of t cubed minus 10t squared plus 24t dt. We know the antiderivative already. It is 1 over 4 t to the fourth minus 10 over 3 t cubed plus 12 t squared, but this time we plug in 0 and 4. This is 1 over 4 times 4 to the fourth minus 10 over 3 times 4 cubed plus 12 times 4 squared minus, if we plug in 0, we end up with 0 in all three terms. To evaluate this, we factor out 4 cubed. 4 to the fourth power divided by 4 is 4 cubed, so we end up with 1 here, minus 10 over 3 left, plus 12 is 3 times 4, but we use the factor of 4 and 4 squared to factor out 4 cubed already, so we end up with 3. This is 42 2/3 meters. And this is the distance traveled between time 0 to time equals 4 only. This is already positive, so we do not need to take the absolute value. Next, we still need to find the distance traveled on the integral 4 to 6 time equals 4 to times equals 6. To do that, we find the definite integral from 4 to 6 of the velocity. And this is the integral from 4 to 6 of t cubed minus 10t squared plus 24t dt again. We use the same antiderivative, 1 over 4 t to the fourth minus 10 over 3 t cubed plus 12t squared. And we plug in 4 and 6. If we plugged in 6, then we get 36. That's what we got earlier. And if we plugged in 4, we will get 42 2/3. And so this is -6 2/3 meters. But this is the displacement, not the distance. The distance is therefore the absolute value, -6 2/3 or 6 2/3 meters. The distance traveled during the first time interval from 0 to 4 is 42 2/3 meters, and the distance traveled during the second time interval is 6 2/3, and so the total is 49 1/3 meters, and this is approximately 49.33 meters.